Large angle stability analysis mode in Hydromax can be used to calculate a GZ curve of writing moments based on the inputs of the load case of masses that are applied to the vessel and the range of heel angles that you'd like to investigate. There's also a comprehensive library of stability criteria which are used to assess compliance with the relevant criteria for the operational area of the vessel. The outputs are a range of hydrostatic properties at each angle, the GZ curve of course, and it's also possible to display some other graphs such as curve of areas at each angle of heel and other properties. Let's switch over to Hydromax and take a look at how we set up and run large angle stability. Choose large angle stability from the analysis mode drop down, and then from the analysis menu we can see that there's a couple of items that we need to enter: the range of heels and the type of trim to use. So for our range of heel angles, I'm going to go from -30 degrees to 180 degrees in steps of 10 degrees, and I'm going to heel in the starboard direction. At each angle of heel, it's possible for the vessel to trim to a different condition. So I can allow it to free trim to the current load case that I'm looking at, or I can lock the trim to be a fixed condition. We can use either of those choices. I'm just going to leave it at fixed trim for the purposes of this exercise. And I'm going to do my analysis in the departure condition, so with the maximum load. If I run my stability analysis, you can see that the vessel is heeled over through the full range of stability, and then the results of my analysis I can display in the results window. We can see each of the hydrostatic properties that I've chosen to display and the range of heel angles with the properties at each angle of heel. As we saw before, I can select a heel angle, go to the body plan and choose select view from data to see the results at that particular angle of heel. To see my results graphically, of course, I take a look at my GZ curve in the graph window, and we can see the properties of the curve are automatically annotated. So we have our maximum GZ, the point at which a particular down flooding is immersed, vanishing stability and so forth. At the moment I've got a couple of stability criteria turned on for severe wind and rolling, and so we can see that the heeling arms from those two criteria are also displayed on this graph. Let's take a look at how those criteria are set up. If I open the criteria window, we can see that we have a large range of criteria in here. So we've got a range of different coast guards, navies, and of course the IMO. If I expand out the IMO part of the tree, we can see that within the code on and text stability, I've selected a number of different criteria. Here we have a criteria on area under the GZ curve, another criterion on maximum GZ, the severe wind and rolling criteria that I mentioned earlier. For each of these criteria, as we select them, we can see on the right hand side of the dialog the exact specification of what that criterion is checking. So in this case it's checking an area from the greater of 30 degrees to 40 degrees or the first down flooding angle, and making sure that that area under the curve is greater than a certain value. There's also a help section for each of these criteria. So if I recalculate and close that, we can actually go to the criteria results window where we can see for each of these criteria what the intermediate values are, the actual values versus allowable, and whether or not these criteria pass or fail according to the code checks that I've chosen. If we see a criteria that fails, it'll be highlighted in red, and the reason for the failure will be noted in the report. Back in the graph window, we also have some other graphs that we can show. We can show a curves of form graph that shows how different properties vary with angle of heel. So for example, we can see how waterplane area varies or how the prismatic coefficient varies at different points. We can also display some criteria that are relevant to yacht design. The maximum steady heel angle is a way of defining some of the properties of the vulnerability of the yacht to being knocked down by gusts of wind. In our data format setup, we can define the criteria that specifies how the heeling due to wind gust is calculated. we can specify a range of different wind gusts to consider, and then each of these can be computed for the vessel that we're looking at. And this produces a range of areas on the graph where the vessel is not vulnerable to gusts or where it is vulnerable to gusts and squalls. Dynamic stability is also useful. That's a calculation of the total area under the GZ curve up to a particular angle, and it's a measure of the amount of energy required to heel the vessel to that angle. It's a useful tool for assessing a dynamic phenomenon such as sudden rolling due to gusts of wind and the ability of the vessel to resist that rolling. So large angle stability allows us to compute all of the vessel's properties at ranges of angles of heel and ensure compliance with different criteria. Thank you for watching.